This is going to be Chapter 9, Quadratic Equations and Functions. So before we get to the quadratic equations, I do want to review a little bit of factoring. So basically what factoring is, and it'll prove to be a little bit easy to solve some basic problems. If you have some sort of expression that looks like this, and you want to be able to factor, one of the things that you can do is you can pull out the greatest common factor that they both have in common. So for example, I notice here that you have a 2 and a 4. So one of the greatest things that I can take out is a 2 for both of them. I can't take out a 4 because this 2 is not divisible by 4. So I'm going to take out a 2. Now I'm going to look at the x's. Well, I have an x squared here, and I also have an x cubed. The greatest amount of x's that I can take for both of them is an x squared. Okay, so that's what I can take out. Now if you take y squared and y to the 5th power, the greatest amount of y's that I can take out is a y squared for both of them. Okay, so what's left in the inside? So after I am taking out all of those things, well, I took out a 2 for this one, so that one's gone. I took out 2 x's from this one, and I took out 2 y's from this one. So I don't have anything else, but when I distribute it back, I need to have a placeholder. So I'm going to put a 1 there, okay? Because when I distribute it back, I want to get this term back. Still have a plus. I took out a 2 from the 4, so I'm going to be left with a 2. Okay. I took out 2 x's from this x cubed, so I'm left only with 1x. And then from this y to the 5th, I took out 2 y's, so I'm left with y to the 3rd power. Okay, and if you notice, if I multiply this back, 2 times 2 gives me 4, x squared times x gives me x to the 3rd power, y squared times y cubed gives me y to the 5th power. So this is what factoring really is. So one portion of factoring. So here is where you want to take out a couple things first and then leave whatever is left over. And as you can see, these two terms, we cannot get rid of anything else. Okay, we can't factor anything else. So then I'm done. But I'm pretty sure that most of the factoring that you have seen actually doesn't really look like this. It looks more like this. So factoring trinomials. So maybe some of the factoring has looked something that looks like this. X squared plus 7x plus 10. This is probably some of the factoring that you're probably used to and you're going to be using for a while. So what I look here is that I first need to think of 2 different things that will FOIL out to get this thing. Well, one way that I can get an x squared is by multiplying it by x and x, because x and x is going to give me x squared. Now, what do I do with this 10 and with the 7? Well, one of the things that you can do is do this little diamond method and think about what 2 numbers multiply to get this 10 and add up to get this 7. And you'll see why we're doing it this way. So this number all the way at the end is a number that we're multiplying. Okay, and this one in orange is the one that we're adding. So this is the one that we're adding, and this one's the one that we're multiplying. So think about 2 numbers that multiply to get 10 and add up to get 7. In that case, that's going to be 5 and 2. And they're both positive because 5 times 2 gives me 10. 5 plus 2 gives me 7. So these 2 numbers are going to go here. Plus 5 plus 2. The order doesn't really matter. And that is my answer. Now you're probably wondering, why is it that this one's multiplication, this one's addition? Well, let's FOIL it out. If I have x plus 5 times x plus 2, x times x is going to give me x squared. X times 2 is going to give me plus 2x. 5 times x is going to give me plus 5x. 5 times 2 is going to give me plus 10. So if you notice, this 10 corresponds with this 10. That 10 came from multiplying these 2 numbers together. Now this part was done by multiplying this x times 2 and this 5 times x. So that's how I got this 7, this thing, because this 2x plus 5x is going to give me 7x. So this 7x comes from the fact that I'm adding those same numbers. Okay, so that's basically the gist of it. So let's do a couple more examples before we get to the one that's a little bit more more crazy. So what do you think x squared plus x minus 12 is going to be? Okay, so we're going to do the same thing. Two numbers that multiply to get this negative 12. So notice that I'm incorporating the negative there, and add up to get 1. Since there's no coefficient in front of it, it's going to be a 1. Okay, so what do you think this is going to be? Well, in this case, it's going to be a 4 and a 3, because 4 times 3 gives me 12. Notice 6 times 2 also gives me 12, but 6 plus 2, those combinations cannot give me a 1. So now, how can I make this a negative and make sure that when I add them, I get this a positive? Well, if I make this a negative, 4 times negative 3 is going to give me negative 12. 4 plus negative 3 is going to give me positive 1. So my factored form of this is still going to be x and x. This is going to be plus 4, and this is going to be minus 3. And you can always check your work by just FOILing everything out. Okay, now let's do this next problem. Let's say, for example, we had negative 5a squared minus 15a minus 10. Okay, so before we do this problem, before you start going to the diamond method, first let's see, can we take anything out that they all have in common? Well, we can't take out a variable. So instead, we notice that we have a negative 5, a negative 15, and a negative 10. And all of those are divisible by 5. So I can take out a 5, and not just a 5, but a negative 5. And what's going to be left on the inside? Well, got rid of a negative 5, I'm left with an a squared here. Took out a negative 5 here, I'm left with a positive 3a. Took out a negative 5 here, I'm left with a positive 2. Okay, now this part is the thing that I want to factor. Okay, so what is this going to be? Well, I need two numbers that multiply to get to this 2, and also add up to get to this 3. Okay, well, that's easy. It's just going to be 2 and 1. So I'm going to have a plus 2, a plus 1. Okay, and this is going to be my final answer. Okay, so not too terrible. You just need to factor out something in the very beginning. Now, the ones that are a little bit more tricky are these types of problems. So when you have something that looks like this, 6x squared plus 11x plus 4. Something like this is a little bit more complicated because now, if you notice, we've been dealing with problems where the square term only has a 1 in front of it. So notice a 1 and a 1. So there's nothing that's in front of it. Now we have to deal with the 6. So one of the things that you can do, there's many different ways that you can do this problem. I don't care what method you use. This is one method that you can use, and I call it the AC method. Basically, what you're going to do is you're going to multiply the first and the last numbers together. So first thing is multiply the first and last term together. Maybe I shouldn't say term, maybe I should say coefficient. So the numbers. So in this case, it's going to be 6 times 4, okay, which in this case is 24. Okay, then after you do that, you are going to think of two numbers that multiply to get 24, which is the one that we just had, and add up to get 11. Okay, that's what I want to do. Okay, so the first thing that I'm going to do is I'm going to multiply this 6 and this 4, which gives me 24. Then I'm going to think of two numbers that multiply to get this 24 that I just figured out and add up to get this 11. Okay, so can you think of two numbers that can multiply to get 24 and add up to 11? Well, that should be 8 and 3. Okay, now how am I going to do this? Okay, so there's many different ways that you can do it. One of the things that I really like doing is the box method. I like having this little box. And the way that this box works is that I take the first term, the 6x squared, and I put it here. I take this 4 and I put it here. Okay, so those go on the diagonals. What do you think goes in these two entries? Well, that's going to be the 8 and the 3. Okay, now make sure that you always have x's here, because remember, 8x plus 3x gave me 11x. So don't forget about the x's. And all we want to do now is just factor. Okay, factor horizontally and factor vertically. Okay, so what can I take out this way? So I can take out an x, because notice that this has an x and this has an x. And then between 6 and 8, something that I can take out is a 2, because they can all divide into 2. Here, from 3 and 4, there's nothing that I can really take out, and I can take out an x because this one doesn't have an x. So the maximum amount of things that I can take out is just a 1. Okay, now top and bottom, from the x's, I can take out an x, and from the 6 and the 3, I can take out a 3. And then from here, I can't take out an x, but I can take out a 4. Okay, now, how do I know that this is correct? Well, I can just multiply them. 2x times 3x gives me 6x squared. That's correct. 2x times 4 is going to give me 8x. 1 times 3x gives me this 3x. And then this 1 and this 4 gives me 4. So what I'm going to get is actually the following. I take this term, 2x plus 1, and I take this term, 3x plus 4. Okay, and that is my final answer. Okay, so if you didn't learn it this way, that's okay. You can do any other way that you've learned in high school or whenever that was, but this is just one way that I find useful. Okay, so let's do another problem so that we kind of can get this box method down. So we'll do 2 more problems. So the first problem is going to be 3x squared plus x minus 2. Okay, so you can always start off with a box if you want to and start putting everything in there. So you can put the 3x squared here. You can put the minus 2 down here because there's a minus 2. Now what am I going to do with this 1? This 1x, okay? So you can start putting an x there if you want to, if you really want to, so that you won't forget it. So remember, the first step was to multiply the first number and the last number. So that's 3 times negative 2, which gives me negative 6, okay? So that's the first thing. Then I'm going to think of 2 numbers that multiply to get this negative 6 and adds up to get this middle number, which is x, which is a 1. Okay, in this case, the answer is going to be 3 and 2. Okay, now I need to get a negative, but I want to make sure that this is positive, so this should be a negative. So that means this one's going to be a 3, and the other one's going to be a minus 2. Okay, all right, the order doesn't matter. You can put them in whatever cell you'd like. Okay, now we're going to factor out horizontally and vertically. Okay, so from here, I can take out a 3 and an x, so a 3x. From here, I can take out a negative 2. Top and bottom, I can take out an x, and that's all I can take out. And from here, I can just take out a 1. Okay, now, the negatives are funky, but one way to check is make sure that you multiply this 3x times this x. That gives me 3x squared. This 3x times this 1, that gives me 3x. That's correct. This negative 2 times this x gives me negative 2x. This negative 2 times this 1 gives me a negative 2. So if for some reason the negatives don't add up, just put in the negative wherever it's not working out. So for example, if I didn't have a negative here, then notice that I would have 2 times x. That does not give me a negative 2x. So I would have to make this negative. I couldn't make this negative because then when I multiply it by this 3x, I will not get a positive 3x. So my answer is just going to be 3x minus 2 and then x plus 1. This is going to be my solution. Okay? Alrighty. Now, you try this one. So let's say we had 3p squared minus 2p minus 5. What would that factor into? So why don't you try it out? I'll give you the answer. That way you can check your work. The answer is going to be 3p minus 5, p plus 1. Now, if you ended up flipping them, you ended up getting p plus 1, 3p minus 5. That's still correct. Okay, so try it out if you'd like. And that's it for this one.